Hello students, in the last session we completed sums that are related to vectors. Okay, so we did complete around 11 sums. In this session we will be doing like next 12 sums that are mainly related to relative velocity, and then some sums that are related to projectile motion. Fine. So in this session we will do like sums that are related to two parts, which first one is like relative velocity, and then we will do sums that are related to projectile motion. Fine. So in the next session, which means in the third session, we will complete sums that are oriented towards projectile motion. We'll complete all those things, and then we will do sums related to uniform circular motion. By the way, we will also complete previous year questions. Okay, so 21, 22, 23, last 3 years questions will also be done, right? Fine, so let's jump into it. So let's see the 12th sum. So in the 12th sum, they have given the speed of a swimmer in still water is 20 meter per second. Fine. So this sum is based on the relative velocity. Let's see the sum. So what they have given over here is a swimmer whose speed in still water is 20 meter per second, which means this is the maximum potential with which he could actually swim. Okay. Then they have given us the speed of the river is 10 meter per second and is flowing due east, which means it is flowing towards east with a speed of 10 meter per second. Okay, fine. Then they have given us if he is standing on the south bank, okay, and wishes to cross the river along the shortest path. Okay, so shortest path actually means he has to reach the exact opposite point on that bank. Okay, so I'll draw the diagram, you'll get it. Anyway, he has to reach the opposite side of the bank with shortest path. Okay, which means it should be a straight line. Fine. The angle at which he should make his stroke with respect to north is given by. So in which direction he should actually make his stroke so that he reaches exactly the opposite point. That's what we are supposed to find here. Okay. So let me draw a diagram. You'll get it. So there is a guy who is standing on the south bank. Okay. And then this person actually wants to reach the other side of the bank. Fine. That too with the shortest path, which means he has to reach the exact opposite point, right? So he has to reach the exact opposite point, which means he has to reach this point. Fine. Okay. So what they're asking us to find is in which direction he should make the stroke. So in which direction he should actually swim so that he is going to reach the exact opposite point. Fine. So in the first situation, if he is swimming exactly in opposite direction with a speed of 20 meter per second, then what will happen to him? The velocity of the river will also gets added to it, right? So the velocity of the river is actually towards the east. Okay. So this will be like west, and this is like east. Okay, so when you get it, it will be looking something like this, WEB. Okay, so west and east, in order to remember this one clearly. Okay, so velocity of the river was actually equal to 10 meter per second. Fine, so that's the data that they've given over there. If he is swimming exactly opposite, then in that situation 20 meter per second will be towards the north, and then velocity of the river will also get added to it, which means that will be 10 meter per second towards the east, and you'll have the swim of that person towards the north. So the relative velocity will be towards something towards northeast. Okay, so that's how it's going to be, which means in that situation he will reach a point that is actually at certain inclination towards the starting point. Okay, so that shouldn't be the case. What I need to find here is he should reach the opposite point of the bank with the shortest path, which means he has to swim in a straight line. Okay, so if it has to be a straight line, then obviously he has to swim upstream, which means he has to swim against the flow of the river. Okay, so it is pretty obvious he is going to swim at certain inclination towards the west, so that velocity of the river gets nullified by some of his work that he's putting into it, and then he's moving exactly opposite to it, which means he will swim with his maximum effort at certain inclination towards the west, which means 20 meter per second will be at certain inclination. Okay, as they have given us clearly, this is like a shortest path, therefore he will swim at certain inclination which is like 20 meter per second. Obviously 10 meter per second will be towards the right in this situation. Then his velocity towards the north will be less than that of 20 meter per second. Okay, so from his maximum potential, some part of his work will be used for the swim against the upstream. Okay, so leftover velocity will be towards the north. That's what I intended to tell you. Okay, so you should be clear with the things that I have discussed here. Fine. So if they're given in the question as shortest time, then in that situation it is pretty easy. So he is going to put his maximum effort exactly towards the north, which means 20 meter per second will be towards the north, and then maximum velocity will be oriented towards the north. Okay, so that's how it is going to be. And then 10 meter per second will be towards the right, okay, which means towards the east. So in that situation, he will swim at certain inclination. So that will be the shortest time. In the situation, he is going to reduce his velocity towards the north by swimming upstream towards the west. Okay, so that's how it's going to be, right? You shouldn't have any doubt in the stuff that I've discussed now. Okay, it should be clear. Now we are ready to solve the sum. Fine. So he is going to make a stroke at certain inclination. Fine. So they are also asking us to find in which inclination he has to make the stroke. He will make stroke towards the west, right? So the option should be like 45-degree west or 30-degree west, 60-degree west, okay? So how should I actually consider the angle? It should be considered with respect to the north, okay? So the angle should be something like this. This angle should be considered, okay? I'll have to find this theta. So now let us build a triangle over here. In this situation, this velocity was equal to 20 meter per second, got it, and the velocity towards the right, which was the velocity of the river, was actually equal to 10 meter per second. Fine. So now I have got 20 meter per second at certain inclination and then 10 meter per second, which was one of the sides. Obviously, this looks like a right angle triangle. Therefore, I'll be able to use like Pythagoras theorem, sine theta, cosine theta, or Pythagoras theorem. Let's see what I could actually use. So in order to get the theta, either I should use like sine theta or cosine theta. In this situation, it was like opposite divided by hypotenuse, right? So if it was opposite divided by hypotenuse, then obviously I'll use sine theta. Therefore, you will have sine theta, which is equal to opposite side, that was like 10 divided by 20, which was equal to 1 divided by 2, right? So if so sine theta, which is equal to 1 by 2, then in that situation theta should be equal to 30 degree, right? So the answer here is theta was equal to 30 degree. Fine. So 30 degree west with respect to the north. Okay, so they have given us clearly the stroke is made, the angle is found such that with respect to the north. Okay, so that's how I'm going to make my stroke, right? So the answer here is 30 degree west. Fine. You shouldn't have any doubt in this sum. So this is more like a conceptual based sum. Okay, so there isn't much to solve this sum. The thing is, you should be clear with the concept and the logic that I'm telling you, right? Let's move on to the next one. Next sum is two boys are standing at the ends A and B of a ground where AB equals A. Okay, so this sum is also based on a relative motion. What they have given over here is there is two person, okay, two guys who is standing at the end A and then B. Okay, the distance between those 2 points is equal to small a. That's what they have given in the first statement. Then the boy at B starts running in a direction perpendicular to AB with velocity v1. Okay, so that the person in the B starts running, fine. So that too perpendicular to that distance AB, fine, with a velocity v1. So that's the second statement. Then you have got the boy at A starts running simultaneously. Okay, that simultaneous situation, the boy at A starts running simultaneously with velocity v and catches the other in time t, where t is. So I'll have to find a relation for this time t, okay, with respect to the distance A and then the velocity v and v1, right? I'll draw a diagram, you'll get it. Fine. So you got like 2 points, which is like A, B, right? Whichever direction you take it, no problem. So in the situation, I took the direction perpendicular, vertically, okay? So you have got something like this. Let's put this to be like A and let's put this to be like B, okay? So here what actually happens is the boy at B starts running in a direction perpendicular to AB, right? So this distance is actually equal to A and the boy at B starts running perpendicular with a velocity v1. So that's what they've given. Next, what the person who is standing on the A is doing is actually, he is running at certain inclination such that this guy is going to catch the person B at some time. Okay, so I'll have to find the time. I'll have to find the relation for the time t. Okay, so the hidden hint over here is he has to have horizontal velocity that is equal to that of this v1. That is when the guy A will obviously be able to catch the guy B, okay, or else he'll not be able to catch, right? It is pretty obvious, fine. So if the person A has to catch the person B, then horizontal velocity has to be same. If the horizontal velocity was greater than this one, then he will actually cross this particular point before this B comes to that point. Then obviously those two persons will never meet, fine. If the velocity B1 was less than v1, okay, if this velocity was less than v1, then in that situation the boy B would have crossed cross that particular intersection, but the boy A will reach after some time. Okay, so in both those situations, A will not be able to catch the person B. Therefore, horizontal velocity of A should be equal to that of the horizontal velocity of B, which means it should be equal to V1. So that's the hidden hint. Okay, so with that hint, we will be able to solve this sum, right? So now let me draw a diagram for A. So he is going to run at certain inclination that will be like V. They have given us the velocity. So the magnitude of that particular velocity is equal to V. In that situation, if I resolve these two vectors, so if I end up resolving those two vectors, then horizontal velocity will be equal to V1 and the velocity that is perpendicular to it, which means that is helpful to cover the distance AB, that small a, right? So the perpendicular velocity will be something, let's put it this way, Vy in the situation, fine. So this thing will help us determine the time, fine. So at what rate he is actually covering this distance. So that will give me the possibility to find the time. Therefore, in the situation, velocity Vy will be equal to distance divided by time, right? So instead of distance d, I'll substitute like a, and then for the time t is something that I need to find. So that's the hint that I need to find, right? So for distance, I substituted like a, and then for time t, I substituted straight away time t. I'll have to find the relation for this time t, right? So in order to get this time t, I should be able to replace this Vy with some combination that are related to V and then V1, fine. So it seems to be pretty obvious. If I put like Pythagoras theorem into it, then obviously I'll be able to get the velocity Vy in terms of V and then V1. If I substitute that one over here, then I'll end up getting the time t, right? So that those are like straight away solving. So instead of Vy, what will I be able to substitute? So for Vy, I'll be able to do it such that hypotenuse square minus one of the side square, right? So you'll have hypotenuse square V square minus V1 square, right? I'm doing it straight away, and then you take root to it. That will be like my Vy, okay? So for Vy, I'm going to substitute root of V square minus V1 square, which is equal to the distance, which is like a divided by the time t. What they're asking us to find is the time t. Therefore, if I do the rearrangement thing, I'll get the time. Okay, so the time here is t, which is equal to a divided by root of v square minus v1 square, right? So the answer here is a divided by root of v square minus v1 square. Okay, so option 4 will be the answer, right? So here they have just put the root for the entire term and they have put like a square, right? If I take root for a square, then I'll end up getting a divided by root of v square minus v1 square. So they have given us a step before to it, right? Therefore, the answer here is option 4, right? You should be able to understand this one. So the solving part is actually easy. The only hint that you need to know is the horizontal velocity of the person A and person B has to be same. That is when they will be able to catch each other. Fine. In order to get the time, the vertical velocity, okay, that downward velocity, that's going to play the role to get the time. Okay. So velocity equals displacement divided by time. So instead of displacement, I substituted that small a, which they have given in the question. So to get the time, I just did the rearrangement thing. I got the time. Fine. You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is the width of river is 1 kilometer. Fine. So they have given us the width of the river. Obviously, this sum is based on relative motion, right? The velocity of boat is 5 km per hour. Fine. So they've given us the velocity of the boat, which is equal to 5 km per hour. They didn't give us anything extra, which is like in still water, something like that. Therefore, most likely this should be like resultant velocity of the boat. Okay. Anyway, while doing the sum, we'll get it. The boat covered the width of the river in shortest time, which is like 15 minutes, which means the boat has put its 100% effort towards the north. Okay, so if I draw the diagram in such fashion, which means the boat has put its 100% effort towards the exact opposite end of the bank, therefore it is going to travel with certain inclination. Fine. So that is something that we have explained in a couple of sums ahead. So same logic, but the thing is they are asking us to find the other part, which is like then the velocity of the river stream is. So what I need to find is the velocity of the river stream. Fine. Got it. So if I draw a diagram, the way I drew it for the before sums, you will have a boat which is standing on the south bank. Okay, let's consider the boat to be standing on the south bank. Okay, so and then this boat has to reach the other end of the bank in a shortest time, which means it will put its 100% effort towards the exact opposite point. So that is going to be the north side in this case. Therefore, the velocity of the boat will be towards the north. Okay, so if that was the case, what I need to find here is the velocity of this river stream. Therefore, let's consider the velocity of the river stream is towards the right. Therefore, velocity of the river stream will get added into it. And then what I need to find is VR is something that I need to find. Okay, so what they've given us extra hint is they've given us the distance between the river, which means the width of the river is equal to 1 kilometer. Got it? So this is something that they have given over here. And then the velocity of the boat is actually 5 kilometer per hour. Okay, so they haven't given anything that is related to still water. Then obviously this should be the velocity of the resultant vector. Okay, so I know the answer straight away. I know the answer already, therefore I'm putting it straight away. So they haven't given us anything that is related to still water, therefore I'll put it for the resultant vector, which will be like at certain inclination you will have the resultant vector to be velocity to be like 5 kilometer per hour. Okay, what I need to find here is this vertical component, I mean is this horizontal component. So to get this vertical velocity, which means the velocity of the boat in the still water, what I could do is I know the distance width of the river, and the same way I know the time it has taken to cross the width of the river in shortest time. Okay, so if it has to be like shortest time, then maximum effort of the boat will be put vertical. Therefore, to get this vertical velocity, I know the distance, same way I know the time. So to get the velocity, it will be like displacement divided by time. Therefore, the vertical velocity will be equal to, which means velocity of the boat in still water will be equal to displacement, which will be like 1 kilometer. See, if I look the option over here, everything is in kilometers. Okay, therefore I didn't convert it to SI units. I'm just doing it straight away. So 1 kilometer divided by, I'll have to put the time, right? So to get the time, it's like 15 minutes. In hour, it will be equal to 1 by 4 hour. Okay, so 1 quarter. Therefore, that will be equal to like 1 by 4 hour, which is nothing but 4 kilometer per hour. Okay, so now I have got the vertical velocity of the boat, which will be equal to 4 kilometer per hour, which is nothing but the still water speed of the boat. Okay, so 5 kilometer per hour is actually the resultant velocity. And then only thing which I'll be able to get is velocity of the boat in still water, that will be equal to like 4 kilometer per hour. Then obviously this 5 should be the resultant vector, right? So now you'll be able to get that stuff. Okay, what I need to find here is the velocity of the river. So it is pretty obvious. I'll be able to use the Pythagoras theorem, right? If I use the Pythagoras theorem, you should be clear with this one. 4 square plus 3 square will give me 5 square. Therefore, velocity of the river will be equal to 3 kilometer per hour. Okay, so now I have got the velocity of the river, which is nothing but the 3 kilometer per hour. Fine. So these are like easy sums. You should be clear with this sum. Only thing which is confusing in this sum is actually the 5 kilometer per hour speed. They haven't mentioned anything that is related to still water. Therefore, I put it straight away for the resultant vector. Fine. And then it seems to be clear. Velocity of the boat in still water could actually be found using the width of the river and then the time taken, right? If I divide those two things, I'll end up getting the velocity of the boat in still water. Fine. You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is a projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with the horizontal. Fine. So from this sum onwards, you'll get sums that are related to projectile motion, right? So you got around like 3 sums that are related to relative motion. So from this one onwards, the sums will be based on projectile motion. Okay. So the first statement that I've given over here is a projectile is fired at certain inclination with a velocity of 5 meter per second and the inclination was equal to theta. Okay, so then they have given another projectile fired from another planet. Okay, so first one is from the earth. Okay, and then the second projectile was from another planet. Another projectile fired from another planet with a velocity 3 meter per second at the same angle follows same trajectory with this, which is identical with the trajectory of the projectile fired from the earth. Okay, so which means, let me draw a diagram. So you got a projectile which is fired on the Earth's surface at an inclination theta, and the velocity was equal to 5 meter per second. Okay, it followed a it followed a trajectory of some trajectory. Okay, same way you are going to fire another projectile in some other planet. Okay, so that's an imaginary situation where you got a ball or a projectile which is thrown at certain inclination and the velocity was equal to 3 meter per second. Okay, so in the second case the velocity was equal to 3 meter per second. The inclination theta was same as that of the theta that you have got on the ground on the earth. Okay, so that's how it's going to be. In both those situations, the trajectory was actually looking the same, which means it has reached the same exact maximum height in the earth was equal to the same exact height that was reached on that particular planet. Same way, the range was also same with respect to the earth and also with respect to that particular planet. Okay, which means it looked the curve, the parabola actually looked the same both in the earth and on that planet also. Okay, but it could have reached that particular point on different times, that the time will not be equal, but the thing they have given clearly is the trajectory of the projectile was actually same, which means the path looked similar. Okay, so that's the only hint. So from that hint, either I will be able to equate height or else I will be able to equate range, or else I could equate that big formula y equals x tangent theta minus half g x squared divided by v naught square cosine square theta. Okay, either I could use that big formula or else I could use these two simple formulas, which means in both those situations height and then the range will be equal, right? In this case, let me choose the height. Okay, even if you choose like range, you'll end up getting the same answer. Fine. So in the second planet, in another planet also, it had the same trajectory, which means in both those situations the maximum height was the same thing. Same way, the range was also same. Fine. Either I could use the formula for range to solve the sum, or else I could use the maximum height. Fine. So let us use like the formula maximum height in in the earth will be equal to v naught square sine square theta divided by 2g. Yes. So you'll have like v naught square sine square theta divided by 2g for the earth. Okay, what they're asking is to find is actually the value of acceleration due to gravity on the planet. So I'll have to find the new gravity, the new acceleration due to gravity on that particular planet. Okay, so I'll have to get the g dash. Fine. And they have given us clearly the gravity on the earth's surface was equal to 9.8. So I shouldn't round it off and put 10. In the situation, I'll have to substitute 9.8. Okay, so v naught square sine square theta divided by 2g was the first case with respect to the earth. So we'll have the same height on another planet also, which will be equal to v naught square. So v naught dash square sine square theta divided by 2g dash. Fine. So if I take ratios, if I match left hand side and then right hand side, if I do ratios, h will get cancelled out. I'm doing it straight away. You should be able to get it. And then theta was same on the earth and also on the planet. Therefore, sine square theta will get cancelled out. 2 will get cancelled out. Okay. So the only thing that will be left will be like v naught and then v naught dash and then g dash. Okay, what I need to find is actually g dash. Therefore, if I just equate these two things, I'll get the answer, right? So if I just equate those two things, because height was actually same, therefore you'll end up getting v naught square. Instead of v naught square, I'll substitute like 5 square, which is equal to v naught dash square, that was equal to 3 square. Okay, so divided by g, which was like 9.8. Okay, so instead of g dash, that's what I need to find, right? So that will be like g dash. Okay, if I just do the rearrangement thing, I'll get the answer, right? So g dash will be equal to 3 square. 3 square will be like 9 divided by 25 into 9.8, right? If I just solve it, I'll end up getting the answer. So the answer will be equal to, so I'll have to do the solving stuff, right? Let me cancel it out with respect to phi table. So you will have, instead of 25, that's going to be like 5. So here you'll end up getting 1.5 and then that's going to be like 45, so 9, 30, that's going to be 1.96, right? So if I do solve it one more time, yeah, you will have, that's going to be like 0 point, instead of 19 it will be like 346, right? So that will be like 9, yeah, and then you have like 1, yeah, that will be like 2, 0.392 into 9, okay? So if I do the multiplication, I'll get the new g dash, right? Just do the multiplication and you will end up getting the answer. So 39, so let's round it off. We'll have like 39 into 0.39 into 9, so it will be like 81, 8, 27, 27 plus 8 will be like 35, okay? So that will be like 3.5, right? It will be like 0.39 into 9. Therefore, if I place the decimal places, you'll get 3.51 and it goes on. So the answer should be equal to 3.5, which is like option 1 in this case. Fine. You should be clear with this sum, right? There isn't much to solving. The hint that is given over here is the trajectory is same. If the trajectory was same, I could use like 3 formulas, the bigger one, or else I could use height, maximum height formula, or else I'll be able to use range. Even if you use the range, same way, sine thetas will get cancelled out. And then you'll just be left with v square and then the g relation. Even if you use range formula, you will end up getting the same answer, right? You shouldn't have any doubt in this sum. Let's move on to the next one. This sum is also simple logic based sum. Let's see what the sum is. The velocity of a projectile at the initial point A is 2i cap plus 3j cap meter per second, okay? So the velocity of the projectile is something that I've given in terms of vectors, 2i cap plus 3j cap. Its velocity at a point B is. So what I need to find here is the velocity at the point B, okay? So this is just a logic based sum. So initially they have given us the vectors, which means it will be like 2i cap and then 3j cap. So what should be the velocity when it hits the ground? So even when it hits the ground, it should have the same energy, okay? We didn't discuss the topic of energy as if now, but we know the only component that's going to get reversed will be like the vertical velocity, okay? Horizontal velocity will remain the same, yet it will have the same net velocity, okay? So the velocity at that inclination will have the same magnitude to that of the initial velocity. Only thing is the direction would have changed, that's it, fine. That too, the vertical direction would have changed, the horizontal direction is just going to be the same thing. So in the first case, the horizontal velocity was equal to 2i cap, so even when it touches the ground, the velocity will be equal to 2i cap, that's going to be same. Only thing that's going to change is the vertical component. So instead of plus 3j cap, you will end up getting minus 3j cap, right? So these are like logic based sum. You shouldn't have any doubt. Therefore, the answer here is 2i cap minus 3j cap, which is like option 1, right? It should be clear. Let's move on to the next one. Next sum is the horizontal range and the maximum height of a projectile are equal. Fine. So they have given clearly range and the height are equal. The angle of projection of the projectile is. So I need to find the theta. Okay. So it is pretty obvious. I'll have to use the range formula and then the height formula. I'll have to equate it. When I equate it, because those two things are same, I'll end up getting the theta. Fine. So rest all other components will get cancelled out. So the formula for range will be equal to V naught square sine 2 theta divided by G. Okay. So that's what it's going to be. So then, so for maximum height, it will be equal to V naught square sine square theta divided by 2G, right? Now let me do the cancelling thing. So if I cancel it out, V naught square will get cancelled out, G will get cancelled out. So the only thing that will be left over here is sine 2 theta, which is equal to sine square theta divided by 2. Fine. So in this case, I'll have to go to the step that is before to this one, to this final result. So in that step, we would have used a trigonometric relation, right? You should be clear with the theory. So sine 2 theta will be equal to 2 sine theta cosine theta, right? If I substitute that one into it, I'll be able to solve it, okay? So if you substitute that one, you'll have like 2 sine theta cosine theta, which is equal to sine square theta, okay? So one sine theta will get cancelled out, sine theta will get cancelled out. Then I'll just have divided by 2. I just left that one, so I'll have like divided by 2. So only thing that will be left will be like sine theta divided by cosine theta, that will be equal to tangent theta, which is equal to 2 into 2, which will be like 4, okay? So theta should obviously be equal to tan inverse of 4. So the answer here is option 2. So theta was equal to tangent inverse of 4, right? It's an easy sum. You shouldn't have doubt. Let's move on to the next one. Next sum is a missile is fired for maximum range with an initial velocity of 20 meter per second. Okay, so I'm going to fire a missile for maximum range. Okay, so that's the hint, with an initial velocity of 20 meter per second, that at certain inclination, if g is equal to 10 meter per second square, the range of the missile is. So I'm just going to fire it with certain inclination, that theta is supposed to produce me the maximum range. Okay, then what should be the theta? That's what I need to first figure it out. If I figure that one out, then range will be easy for us to determine, right? So here, let's take the range formula, r, which is equal to v naught square sine 2 theta divided by g. So that's going to be my range. Okay, so to get the maximum range, what should be this theta, the sine component? If it was equal to 1, so that's the maximum value that I could actually get for theta, sine theta. Therefore, what should be the theta that I need to substitute here so that I get the value to be like 1? So it should obviously be equal to 90 degree. If it has to be equal to 90 degree, then theta should be equal to 45 degree, right? Because 2 into 45 gives me 90 degree. Therefore, in this case, if the theta was equal to 45 degree, if I do the multiplication, I'll get like 90 degree. So sine 90 degree will be equal to 1. So that's the maximum value which I could actually get for the sine component. Therefore, this term goes to 90 degree. If it was like 90 degree, then it will be equal to like 1. Then in that situation, v naught square divided by g gives me the maximum range, right? So let me draw a pictorial representation to get a clear understanding of what I'm telling you. So here, in this case, if I'm going to fire a missile at 45 degree, okay, so if I'm going to fire it with an angle of 45 degree, in that situation, let's suppose this will be my projectile. Okay, if I'm going to fire it with an angle less than 45 degree, then in that situation it will hit the ground quick. Okay, if I'm going to fire it greater than 45 degree, then in that situation it just reaches extra more height, then it comes to the same point range. Okay, so if it was like less than 45 degree, in that situation it just hits quick. If it was like greater than 45 degree, the height is going to be more. In that situation, the range will obviously be small when compared to that maximum range, right? Therefore 45 degree will be the optimal point. Okay, so you could have seen this one in cricket. So when a batsman hits the ball at an inclination of 45 degree, it seems to be like flat, still you will end up getting like 6, fine, because I was able to get the maximum range. Okay, so if I'm able to get the maximum range, in that situation, the ball will obviously cross the boundary line and I end up getting like 6. So that's the flat 6. Okay, same thing here. If I'm going to project this missile at an angle of 45 degree, then in that situation I'll end up getting the maximum range, fine. So obviously from the formula perspective, it is pretty clear. At 45 degree, sine component was equal to 90 degree. Therefore, I ended up getting 1. Okay, so that will be the maximum value. Therefore, in that particular angle, I'll end up getting the maximum range, right? So, R here will be equal to V naught square, which will be like 20 square divided by the G. So, for G, I'll substitute like 10. Okay, so in the numerator, you'll have like 20 into 20 divided by G, which will be equal to 10. If I cancel this one, I'll have like 40. Okay, so the range here was equal to 40 meters. The answer here is option 1, right? You shouldn't have any doubt in this sum. So these are like simple sums. Let's move on to the next one. This sum is a little bit different. Let's see what the sum is. A projectile is fired at an angle of 45 degree with the horizontal. Okay, so I'm going to fire at an angle of 45 degree. Okay, elevation angle of the projectile at its highest point are seen from the point of projection. Okay, so only tricky thing is they have given us something called elevation angle, fine. So when they are telling you to find an elevation angle, it simply means from the point of projection I'll have to draw a straight line. Okay, so here the projectile motion is going to be at certain inclination, which means with respect to that quadratic equation it will look like a parabola, right? But I'll have to get the elevation angle, which means at what angle should I lift my eyes so that I'm able to see the highest point that the ball has reached. That's what I'm supposed to find here. Okay, that the projectile has reached. Okay, if I draw the diagram, you'll end up understanding it clearly, right? So The thing that they are asking us to find is elevation angle of the projectile with respect to at its highest point as seen from the point of projection. Okay, let me draw the diagram. So this will be my ground surface, and then so this is my ground surface, right? And then I'm going to throw the projectile, fire the projectile at an inclination of 45 degree. Okay, so this will be my throw. So it follows a trajectory with respect to the projectile or parabola, and then it hits the ground. Okay, what I need to find here is the elevation angle with respect to the highest point it has reached. Fine. So in this situation, the highest point that it has reached is this one, which is like h. Okay, therefore obviously the angle of throw was equal to 45 degree. I'll have to get the elevation angle, right? So in order to get the elevation angle, I'll have to join the highest point with respect to the origin from where I threw that projectile. Okay, so this will be my elevation angle. So this is supposed to be my elevation angle. Okay, so I'll have to get this other theta, right? So I'll have to get this theta, whereas the angle of throw was equal to 45 degree. Okay, so that is something different because that is not a straight line that connects the highest point. So whenever they give you like an elevation angle, it is something like this. How much angle you will actually tilt your eyes so that you are able to see that particular point. In this situation, that particular point was equal to the maximum height. Okay, so here it was equal to capital H, and then in order to get the elevation angle theta, it seems to be pretty obvious. This triangle is actually a right angle triangle, right? Therefore, this distance is capital H, that is known. In order to get the hypotenuse, that is like tough, right? But it is easy to get the other side. So the other side here is like half of the range. Okay, so those two things will be symmetrical, then obviously this will be like r by 2, this will be like r by 2. Therefore 1 r by 2 gives me one of the sides, right? So this distance was actually equal to r by 2, right? So now I'll be able to use the tangent theta straight away, and then I'll end up getting the theta. So theta is something that they're asking us to find, right? Yeah, so theta will be like elevation angle, right? So to solve this one, tangent theta will be equal to h divided by r by 2, opposite divided by hypotenuse, so that will be like h divided by r by 2. Okay, so instead of height, I'll substitute the formula, which will be equal to v naught square sine square theta divided by 2g. Okay, so instead of theta, I'll substitute like 45 degree because I've taken the elevation angle to be like theta. Therefore I do not want to confuse you with two thetas. Okay, so I'll substitute straight away sine 45 degree, something like that. Fine. So for capital H, if I substitute the formula, you'll have like v naught square sine square 45 divided by 2g. Got it? G will get cancelled out, so there is no point in worrying what to put 9.8 or 10. Therefore you'll have like divided by 2g, and then if I do like one more division, h divided by r by 2, right? So you'll have v naught square sine 2 into 45 degree. Okay, 2 into 45 degree divided by g. Yeah, so g's will get cancelled out, it will get cancelled out, and then you have got v naught square, those two things will get cancelled out, right? So if I do the solving, I'll get the answer. So here you have one more 2 in the denominator, right? Because it's like r by 2, therefore you'll have like one more 2 in the denominator. Fine, so those two 2's will also get cancelled out. Fine, so let me cancel that one also. So this 2 and this 2 will get cancelled out, right? So if I just solve that sine component, I'll end up getting the tangent theta. Then let's flip it to get the theta. Okay, so if I do the solving, you will have sine 45 degree the whole square. So what was sine 45 degree? Sine 45 degree was actually equal to 1 by root 2. 1 by root 2 the whole square gives me 1 by 2. So that will be in the numerator. Then in the denominator you have like sine 90 degree. So sine 90 degree is obviously equal to 1. So that will be my tangent theta, right? Then theta will be equal to tan inverse of 1 by 2. That's it. So the answer here is tan inverse of 1 by 2, which is like option 3, right? You should be clear with this sum, right? So this is actually a simple sum. Only tricky part is the elevation angle. Okay, so you might have known elevation angle in your lower grades itself. Anyway, the elevation is angle actually is how far you are just lifting your eyes to see the uppermost point or the top point that they've given over there. Okay, so how far should I actually tilt my eyes? So in this situation, I'm just placing my head in the point of origin. So how much angle should I actually tilt? That's what they're asking us to find, which will be my elevation angle, right? You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is actually simple one. Let's see what the sum is. The speed of a projectile at its maximum height is half of its initial speed. Okay, so speed of the projectile at the maximum height is actually half of the initial throw speed. Okay, the angle of projection is, I need to find the angle of projection. If I draw the diagram for this one, you will have something like this. I'm just going to throw a projectile at certain inclination with a speed u, and then it follows a projectile. Okay, the speed of the projectile at the maximum height will only be the x component, so you will only have ux, which will be equal to u cosine theta. Fine. What they've given in the question is this speed at the maximum height is actually equal to half of its initial speed. Okay, so u cosine theta will be equal to u by 2, right? If I substitute that one straight away, I'll get the answer. Okay, so instead of u cosine theta, I'll substitute, which is equal to u by 2, right? Just do the solving, you'll end up getting the theta. So those two u will get cancelled out. Cosine theta was equal to 1 by 2. Okay. Then what should be my theta? So theta should actually be equal to 60 degree, right? So these are easy sums, you shouldn't have any doubt. Let's move on to the next one. Next sum is for angles of projection of a projectile at angle 45 degree minus theta. Okay. So we're going to throw with respect to two different angles. One angle is going to be 45 degree minus theta, and the other one is like 45 degree plus theta. Fine. In that situation, the horizontal range described by the projectile or in the ratio of. Okay, so if I'm going to throw in such a fashion which is going to be like 45 degree minus theta, I'll have to get the range for it, and then I'll have to get the range for 45 degree plus theta, right? And then I'll have to take the ratios for it. Okay, so if I get the ratios, then how should actually be, right? So to solve this sum, let's give a value to this theta. Okay, I'll give in a favorable way so that I'll end up getting 2 thetas, and then I'm going to get the range for it. Okay, so if I do the range, let's see what the ratios that I'm going to get. Fine. So in this situation, 30 degree and 60 degree seems to be like a sweet spot. Okay, so to get like 30 degree and 60 degree, what I could do, 45 degree minus theta will give minus 15 will give me 30 degree. Same way 45 plus 15 will give me 60 degree. So the theta that I'm going to choose here is actually 45 minus 15 and then the 45 plus 15. So theta that I'm going to choose is actually 15. Okay, so if I do the solving, let's see how the range actually looks. So the formula for the range will be equal to v naught square sine 2 theta divided by g, right? So for the first one, let me put it as r1. For that, it will be like v naught square sine 2 theta, right? So 2 theta, that gives me like 2 into 30 degree, so that will be like 60 degree divided by g. That I'll divide that one with another one range, which will be like r2, which is equal to v naught square sine 2 theta. So in the second case, it was actually 60 degree. 45 plus 15 will be like 60 degree. Therefore, that gives me 120 degree. Sine 120 degree divided by g. Okay, let's do the cancellation. So v naught square will get cancelled out. G will get cancelled out, right? Only thing that will be left is like sine 60 degree, and then you have like sine 120 degree. For sine 60 degree, we obviously know that will be equal to root 3 by 2, right? Then for sine 120 degree, I told you should remember this graph, right? So sine 90 degree will be like 1, and then it will start decreasing. So the first decrement will give me like sine 120 degree, right? 90 plus 30 degree gives me like sine 120 degree. Then obviously that 2 should be equal to root 3 by 2. Fine. So in this situation, range R1 and then R2 both were just the same thing, therefore these two things got cancelled out. Okay, so the answer was like 1:1. Fine. So the answer here is obviously 1:1. Fine. So if I do a pictorial diagram for this one, you'll get something like this. I have already told you for 45 degree I'll end up getting the maximum range, right? So that will be the maximum range. If I just decrease by the same angle and increase by the same angle, then those two situations you will have the same range, which means, so if I decrease by 15, in that situation, it hit early. That wouldn't be the maximum range. I'll get the maximum range for 45 degree, right? So 45 minus theta gave me some shorter range. Same way, 45 plus theta will also give you the same range. The height will be something different, but the range is going to be the same thing, okay? So this is how you'll have to understand it pictorially. Anyway, we did it using the formulas, okay? So I have just solved it mathematically and I ended up getting 1:1. Therefore, obviously, both those range should be the same thing. To get the understanding, to get clear understanding, I actually drew this diagram, okay? You shouldn't have doubt in this sum. This too is an easy sum. Let's move on to the next one. Next sum is logic based sum. Let's see what the sum is. A particle A is dropped from a height and another particle B is projected in horizontal direction with the speed of 5 meter per second. Fine. From the same height. Then the correct statement is fine. So this is logic based simple sum, statement based sum. So in this situation, I'm just going to drop a ball. Fine. I'm just going to drop a particle and then I'm just going to throw another particle. So this particle is actually A, and then I'm just going to throw another particle with an horizontal velocity that was equal to 5 meter per second from the same point, right? So that's what they've given over here. A particle A is dropped from height and another particle B is projected in horizontal direction with a speed at the same height, right? So in those two situations, how will it reach the ground? That's what I need to find here. It is pretty obvious. The horizontal velocity doesn't constitute to the vertical velocity. Therefore, the vertical acceleration in the situation was given by the acceleration due to gravity. Therefore, both those particles will reach the ground at the same time, but at the different location. Okay, so this thing will have a straight motion kind of kinematic equation. So in the last chapter that we have studied, right? So this will look like a straight vertical motion. In this case, you are having an horizontal component into it. Therefore, this will be like a projectile motion. But anyway, in both those cases, it reached the ground with the same time. But the thing is, it reached different points. Okay. So let's see what they're given in the options. First option is particle A will reach the ground first with respect to particle B. Obviously, that is wrong. Particle B will reach first. Obviously, this too is wrong. Both the particle will reach the ground simultaneously. Fine. Yeah, that thing is right. Both the particle will reach the ground simultaneously. Therefore, option 3 is my answer. Option 4 is both particles will reach the ground with same speed. That's not the case, okay? Both those things will have the same vertical velocity. But this thing actually has horizontal velocity into it. Therefore, the speed is going to be something different for A and B. But the thing is, both the particle will reach the ground at the same time, which means simultaneously. The answer here is option 3. It should be clear. Let's move on to the next one. Now we are into the last sum of the session. So with this sum, all the sums that are related to projectile motion will get completed. In the next session, we will do sums that are related to uniform circular motion. Okay. So the last sum is actually the simple one. Let's see what the sum is. Two projectiles of same mass and with same velocity are thrown at an angle 30 degree and 60 degree with the horizontal. Okay. So we are throwing at an angle of 30 degree and 60 degree with respect to the horizontal. Then which will remain the same? Then what should be same? That's what I'm supposed to find. So here the angle of throw was like 60 degree and 30 degree. So it is like 45 degree plus theta and 45 minus theta. So this sum is actually similar to that of the previous sums that we have seen. Therefore, it should have the same range. Okay. Let's see what they're given in the options. First one is time of flight is going to be same. No. Range of the projectile is actually going to be same. Therefore, the answer here is option 2, right? So you shouldn't have doubt in the sum. So this is actually a simple one, right? So with this, all the sums that are related to projectile motion got completed. Fine. You shouldn't have any doubts in the sums that we have discussed. Fine. So with this, the video gets completed. Bye.